Alright, so we've been talking about process scheduling and how CPUs switch between processes and all that for a while now. There is an important technical term which we need to remember, which is context switch. So it is almost self-explanatory from the name. When a process P1 is removed from the CPU and a process P2 is assigned, all information pertaining to P1 should be updated in P1's PCB and removed from the CPU. Similarly, corresponding information of P2 should be taken from the PCB and loaded into the CPU. This is what context switch is. So I'll explain in simple terms. We know every process has a PCB, a process control block, which stores information about that particular process. State, program counters, accounting information, file information, memory management, all of that. So for every process you have a PCB. Now there is your CPU. Your CPU is currently working on process P1. So it has obviously accessed everything from the PCB. It knows the state of the process, it knows all this metadata, and using this metadata only it is doing whatever it needs to be doing, because you need to know the state of the process in order to be able to send it to a queue and so on and so forth, right? So the CPU, when it is executing P1, it has access to all the information that is stored in the process control block of P1. Let me repeat that statement. When the CPU is executing a process P1, it has access to all information stored in the process control block of that process P1. Now when we say the CPU has to stop working on P1 and move to P2, it should lose access to P1's process control block and it should gain access to P2's process control block, right? So that is what happens. Whatever is the latest situation of P1, that must be updated in P1's PCB, and then that data should be erased from the CPU. The data is still stored in the PCB corresponding to P1, mind it, which is a part of the memory. But when the CPU was working on it, it also had access to this. Now once the modifications are made, it is giving up access. On the other hand, it is going to P2, taking P2's process control block and claiming access of that, because it is going to be working with P2 now. So this switch where you were working on one process and now that you are going to move to another, you are updating that former process up to the latest level to which you worked on it. Then you give up control over all data and all resources pertaining to the former process. Then you pick up information about the latter process, you familiarize yourself with it, and then you start working on the latter. This thing when the CPU does, it is called context switch. Now the problem with context switch is it takes time, and that time is pure overhead. What do I mean by overhead? When context switch is happening, you're not working on any process, so you're not producing any output. So the more time you spend on context switch, the more time your CPU is running, expending resources without producing any valuable output. So especially in a multitasking or a time sharing system, I said the CPU is basically switching so frequently between processes that it is giving you an illusion of efficiency, right? So the thing here is, if you're switching so often between processes, you're performing context switch so often. So technically, you're just wasting a lot of time on the context switch. So that is a point to be kept in mind. It's a question of trade-off. Whether you want a lot of tasks to be finished at the same time, you should be willing to pay the price of context switch overhead and so on and so forth.